Welcome back, folks. In this video, I'm going to talk about the electrical interactions, and I'm going to start my video with some of the basics of electrical interaction. So it's all about the concept of the energy concept we can apply to the electricity now. So the concept of energy says that mechanical energy EM is equal to EKE plus EPE, potential energy. So the same concept we can apply to the concept of electrical interactions, whatever we said in the concept of energy. Now, this is the mechanical energy, means mechanical energy remains conserved and it is equal to the sum of the kinetic energy and the potential energy. Now, let's try and understand this concept with the help of this example. So we are given a pitch ball with a mass of 2.4 times 10 raised to power negative 4 kg with the positive charge of 1.2 times 10 raised to power negative 8 coulombs, initially at rest at the location point A in the electrical field of large charge given in figure. So figure, I will draw the figure here. So this is a negative charge, and then there is this positive here, and then initially the charge is here at rest. So this pitch ball, the mass of the pitch ball is given to me 2.4 times 10 raised to the power negative 4 kg, and then also says that it has this much charge, which is 1.2 times 10 raised to power negative 8 coulomb, initially at rest at point A. So this becomes point A, and then in the electrical field charge at this location, the charge pitch ball has 3 times 10 raised to power negative 7 joules of energy. So it has 3.0 times 10 raised to power negative 7 joules of energy too, of the electrical potential energy given to me. And from here, I can first of all figure out that I have to use the potential energy formula, means it is energy interaction going on here. And when released, the ball accelerates towards the larger charge at the position B. The ball has 1.5 times 10 raised to power negative 8 joules. So it is, once it is released, because this is a negative charge and this is a positive charge. So let me erase this. So obviously the natural tendency of the positive charge is to move towards the negative charge. So once it is released from its location A, it moves towards the charge, it moves towards the negative charge, and then it reaches to the position B. So somewhere here it reaches, and the ball has 1.5. This ball has 1.5 times 10 raised to power negative 8 joules of energy at this point. Find the speed of the pitch ball when it reaches to the position B. I wanted to find out the speed at this location. So as I said, the mechanical energy of a system remains conserved, irrespective of anything. That's the concept we can apply. So what does that mean? That kinetic energy may increase and potential energy may decrease, or the potential energy may increase and the kinetic energy may decrease, but this sum of both the energies will always remain equal. So if the sum is 20, this may be 10 and 10, and this may be 15 and this may be 5, but the sum will remain always 20. So again 20, this may be 4 and this may be 16. So sum will always come out to be 20. So that's the concept we can apply to solve this question. Now, at this particular location, if I say at location A, so the energy at location A will be equal to E mechanical will be equal to potential energy, which is given to us this much joules of potential energy, 3.00 times 10 to the negative 7 plus kinetic energy. So at this location, kinetic energy will be 0 because it is at rest. It is stagnant at the point A. So the total mechanical energy value will be equal to the same as that of the potential energy, 3.00 times 10 to the negative 7. And then when released, this charge moves towards the other side. So it reaches to the point B. At point B, it says that it has energy level of 1.5 times 10 to the negative 8 joules of electrical potential energy. So this is the leftover energy. Remaining has converted into kinetic energy. So EKE, this is what I'm going to write it for. EKE, that's what I'm looking for right now. So mechanical energy is same as what is at location A. So at location B, that will be the same. So EM at location B will be equal to 3.0 times 10 raised to the power negative 7 joules. And then I will just segregate this mechanical energy into the potential and kinetic energy. 3.00 times 10 to the negative 7 is equal to E potential plus kinetic energy. And potential energy at location B is equal to this much. That's given to us in the question. So that will be equal to 1.5 times 10 raised to the power negative 8 plus EKE. And now I can do the algebra and then can solve for the question. So this is going to go on the other side. So 3.0 times 10 to the negative 7 minus 1.5 times 10 raised to the power negative 8 equal to EKE. And then once I'm going to subtract these two values, then I'm going to get the value as 2.85 times 10 raised to the power negative 7 joules, which is equal to EKE. Now we figured out the kinetic energy, which is equal to half mv square also. And if I were to find the velocity, as the question says, find the speed. So that's what I'm trying to find out, speed. So 2.85 times 10 raised to the power negative 7. And then after doing the calculation, this 2 will go on the other side, 2.85 times 10 to the negative 7 multiplied by 2, and this mass will go in the denominator here. So mass will go here, and the mass value is given to us in the question, which is 2.4 times 10 to the negative 4. So 2.4 times 10 to the negative to negative 4 kgs, and this is v square, and square will go on the other side, will become square root 2.85 times 10 to the negative 7 multiplied by 2 divided by 2.4 times 10 to the negative 4 equal to v. So that's how we're going to find out the velocity value. So this will come out to be 4.9 times 10 raised to power negative 2 meters per second. So hopefully you were able to understand how we can apply the energy concept to the electrical interaction. Now I'm going to look into one more question, which is based on the electrical interactions and the energy concept, and try and solve this one. So in this question, uh, I'm not gonna I'm gonna try and solve it, but I'm gonna give you the hint, because this kind of a questions I'm asking you in the assignments also. So I will try to refrain from fully solving this question. So now let's look into this question. So a horizontal parallel plate is given to me. So this is a parallel plate given to me here, and then they are connected to the DC power supply as shown in the figure below. The electrical field between the plate is this much. So electrical field is also given to me, and then also given to me the initial speed, and then accelerates towards the negative plate. Copy the diagram into the picture notebook, and then blah blah different things. And then another piece of information given to me is that find the distance of the positive charge moves towards the negative plate after 6 times 10 raised to power negative 6 seconds. So this is a positive charge which is trying to move towards the negative plate. That's how it is trying to move, and we wanted to find how much distance it has traveled. That's the question. Now, if I can recall from previous physics class, the concept of velocity. So we were given, I'm going back to the basics of the kinematics. So there are five things. One is the final velocity, another is the initial velocity, and then there is time, and then there is displacement delta d, and then there is acceleration. In this case, because it is a vertical, well, it's whether vertical or horizontal, because this is tiny object, so gravity won't make an impact, so I'll call it as acceleration. Now, if you wanted to understand this concept deeply, you can go and watch my video on the kinematics also from physics, previous physics class. So those videos are also posted on YouTube. So now the basic idea I'll give you, that three things will be given to me. I were to ask to find the fourth thing, and then I will neglect the fifth thing, the thing which it is not talking about. So for example, if let's say in a question these three things are given to me and I'm asked to find the displacement, I will neglect the acceleration because we are not talking about the acceleration. And if let's say we are given these three things and we are asked to find the acceleration, and then I will neglect the final velocity because we are not talking about the final velocity. So that's the concept we can apply. And then there are five equations. Those equations are v initial, v final. Oops, I cannot write it right now. Seems like my computer screen has stopped for a second. Let me reconnect it. And uh, it should be, hold on, so it should be here. Yeah, hopefully we guys are back. Yeah. So there are five formulas which make equations around the kinematics. So one is v final minus v initial divided by time is equal to acceleration. Another equation is v initial times time plus half at square equal to delta d. And then the third equation is v final times time minus half at square, which is equal to delta d also. And then another equation is v final minus v initial plus divided by a 2 times times delta t is equal to delta d. And then the final equation is v final square minus v initial square equal to uh, 2 2a delta d. Again, you can, if you wanted to learn the detail of these, you can watch my video on the kinematics. And now in this question, I am asked to find out the displacement in the vertical direction. This is what I've been asked to find out in a given amount of time. The time is given to me that 6 times 10 raised to power negative 6 seconds. So 6.0 times 10 raised to power negative 6 seconds. In this amount of time, how much vertical displacement the object or this charge has traveled? So time is given to me. Time is 6.00 times 10 raised to the power negative 6. I've been asked to find out the displacement delta d. I am asked to find delta d, which we don't know. And what else is given to me? Initial velocity, I can say, is given to me, but this initial velocity which is given to me is in the horizontal direction. As soon as it enters the plates are in the vertical direction, so it will change its position. So this is how it is moving. It's moving in the horizontal direction, and then it changes its position. So initial vertical velocity will be 0. That's what we will assume. We won't take this velocity because this is in the horizontal direction. We will only take the velocity in the vertical direction. So vi in the vertical direction, viy is equal to 0. And then we don't have final velocity, we don't have acceleration. So if somehow I can find the acceleration, I'll be able to solve this question. So I need the acceleration. So why I selected the acceleration? Because in this question, we are given the mass of the sphere. So from mass, I know that there is a formula for force. F net is equal to mass times acceleration. So I can use that formula. That's why I choose to find out the acceleration. So the mass is given to me is 3 times 10 raised to power negative 15 kg. 3.0 times 10 raised to power negative 15. And then acceleration value, we don't know the acceleration value. That's what we are trying to find out. But we don't know the force value also. So we stuck again. So now I'm going to try and see what other piece of information is given to me to find the force value. So we are given the electric field. So I'll erase this. The electric field amount is 1.7 times 10 raised to power negative 5. So E value is given to me 1.7 times 10 raised to the power 5 volt per meter. Volt per meter, that is given to me. And then, uh, is there anything else given to me from where I can find the force? So I will again look into here. We are given a positive charge of this much, 2.6 times 10 raised to power negative 12. So the charge amount is given to me 2.6 times 10 raised to power negative 12. And then I know from chapter number 10 that force is equal to electric E value, E times Q. That's how we can find out the force. Remember in the beginning of chapter 11, we said the electric field value E is equal to KQ1 divided by R square. If I multiply it by Q2, then it's going to become force. Okay. So E times Q will be equal to this value. And these formulas are given to you in your formula booklet too. Now, E value is given to me, charge is given to me, so I'll multiply them 1.7 times 10 raised to the power 5, and then multiply it with the charge value, which is 2.6 times 10 raised to the power negative 12, and that's going to give me the force value. So if I multiply these two, that will come out to be 1.7 times 2.6, which is 4.42, multiplied with 10 raised to the power 12 minus 5, that's going to give me 7. So times 10 raised to the power negative 7. I'm just going to quickly verify my values, whether I've taken the correct values or not. Yeah, this is the charge, and electric field is also given to me. Now I'm going to plug this value, this force value, back into this equation. This equation I'm going to plug in. So force value was 4.42 times 10 raised to the power 4.42 times 10 raised to the power negative 7, and then I can divide both sides by 3.0 times 10 to the negative 15. 3.0 times 10 to the negative 15, that's going to give me the value of acceleration. So 4.42 divided by 3, which comes out to be 1.7. So I'm going to erase it and make some space down here. So that's going to give me 1.47 times 10 raised to the power 15 minus 7, that will be positive 8, equal to acceleration value. That's what we got, meters per second square. Now I'm going to plug the acceleration value into the one of these equations. How I'm going to select which equation I will need to use? So I have the acceleration value here now. So acceleration value is 1.4 times 10 raised to the power 8 meters per second square. This acceleration, I have three things. I have time, I have the initial velocity, acceleration, I have to find the displacement. So I will neglect all the equations which talk about the final velocity. All the equations which talk about final velocity, I'll neglect, and I'll select one of the equation which is left over. This has final velocity, first equation has final velocity, neglect it. This does not have it, so I'll select it. This has, I'll neglect it. This has final velocity, neglected. This has final velocity, neglected. So I'm left with this equation, which I'm going to use to solve my question. Initial velocity times time plus half at square equal to delta d. And then initial velocity, as I said, is 0 times time plus half times acceleration value is given to you, which you figured out 1.4 times 10 raised to the power 8, 1.47 times 10 raised to the power 8 multiplied by time. Time is given to me, which is this much, 6 times 10 raised to the power negative 6. So 6 times 10 raised to the power negative 6 square equal to delta D. So make sure you don't forget to square it, and that's going to give you the final answer. So hopefully you understood how you're going to solve these questions. And yeah, I'll see you with another video. Until then, goodbye.